Hello and welcome to part 4 of the Prep for Calc final exam review. This is part 4 and we'll be starting on question 25. So problem 25 says use the graphs for f and g to solve each of the equations. So solve f of g of x equals 1 for x. Alright, so when we start this, we start out with I guess we end with f would equal 1. And so we have to find out what's going to go in this that equals 1. So we go to our graph and we go to y equals 1. And we see where that leads us. And that's 3. So whenever we plug in 3 for x, we get 1. So that means that we have f of 3 equals 1. Then we have to find out where g of x equals 3. So we go to 3, and we go and we see that happens at 2. So we know that when we plug in 2 here, we get 3, so that means x is equal to 2. All right, and that's the thought process behind these, so I'm going to kind of do that quickly for the next few of them. Solve for g of x equals 5, so g of x equals 5. So I go to 5, and I go over, and that's here at 4. So that means f of x is equal to 4, and that happens at 0, so x is equal to 0. The inverse of f is equal to 3. So when it says the inverse, that means f of x equals to y. So the inverse is y is equal to x. So whenever whenever f of x equals y, we'll find x. And that will be equal to 3. So if we could just go to 3 here, that means x will be equal to 1. Same thing for g of x. We have to find out where it equals 4, and that will be at 3. All right, the inverse of 1, right, so wherever y is equal to 1 for f, and that's at 3, so g of 3. Wherever g is equal to 3, so if we go up, that's all the way at 4. Then we have f of 3 minus f of g, so f of 3 is equal to 1. Your g from the last problem is 4, so 1 minus 4 is equal to negative 3. Find each of the following for the polynomial. So, what I know for the leading term is that's going to be the highest x value. And what I can see here is that we have 2 on this, 5 on this, and this negative 5 term here. So if we multiply those all together, that should be our leading term, because that's going to be the highest order of x's. Because in this polynomial 4x is going to be multiplied together 4 times. And here, 3x is going to be multiplied together 2 times. So if I just write out negative 5 times 4x to the 5th times 3x squared, that is a total of 7 x's. And then I can just put the rest in my calculator, so negative 5 times 4 to the 5th times 2 squared, and that will be negative 46,080. So this is our leading term here, and the multiplicity, or the degree is equal to 7. So the zeros in their multiplicity, so that's easy. We have them right here. They're already multiplied and factored for us. So we can just find 4x minus 3 equal to 0, so that happens at x equals 4x plus 3, x equals 4/3, and 2x plus 3 equals 0. Subtract that over, divide by 3, we get -1/3. So we have x equals 3, and that has a multiplicity of 5. That's the power on the thing, so power on the root, so with a multiplicity 5, and then x equals -1/3, and that is a multiplicity of 2. All right, fill in the blanks. As x goes to -infinity, f goes where? And as x goes to positive infinity, right? So with that, we can look at our leading term here, or negative. Oops. Sorry, to the 7th. All right, and so we know that this is negative and this is odd. So normally what to the 7th would look like is this. But we know that it's negative, so we're going to flip it. And so that means as we go to -infinity, we're going to positive infinity. As we're going to positive infinity, we're going to negative. So negative. Oops, wrong way. Positive infinity, and then to negative infinity. Right, because this is what odd functions look like. Even functions would look like this, going to the same direction. That's positive. That's negative. So this is odd, positive, negative, even, positive, negative. All right, find a formula for the polynomial with the characteristics, write your answers. A degree of 3 has a 0 at -5, and 2 passes through that point. So we have a degree. So what we can start with is we have 2 zeros, right? One at 5 and one at 2. So we know that we have 2 roots here, x plus 5 and x minus 2. And we don't know which one of those have a multiplicity of 2 yet, but we can find out soon. We can look at our end behavior. As x goes to infinity, y goes to -infinity. So as we go this way, we're going that way. So this is going to come up like this, like that. And then as we go this way, we're going that way. So this is going to curl down that way. And that's a negative odd, so we know it's going to be negative. But first, we should figure out what this a term is. And we're going to start by squaring one of them, and we're going to square this one, just for now. So we're going to say that y is equal to this. And so 3 is equal to -a. Right, so that's going to be 3 is equal to -5, or -a times 6, -1 squared, which is going to be 1. So we have, divide that over, we're going to have 1/2 a, and then, so a is equal to -1/2. Okay. So if we plug that -1/2 into this function, you get y is equal to 1/2, because the negatives would cancel out. X was 5, 2 squared. Right, and we have, this doesn't work because of the end behavior. So this function cannot be, right? And so we have to try it the other way. Oops. So y equals -a times x plus 5 squared. Right, and then we substitute in our point. and the negatives are going to cancel out. 36a, and then we divide, and a is equal to 1/12. And so that means we get a final equation of negative 1/12 x plus 5 squared x minus 2. And that meets all of our criteria. Our end behavior is met with that negative sign. It passes through the point, it has the zeros, and it's to the third degree because we have 1, 2, 3 x's. So we meet all the criteria, we have our answer. Number 28. For each of the following given rational functions of g, find each of the following given rational. If it does not exist, write none. Okay, so the intercepts for the graph, that's where y is going to be equal to 0. And also where x is going to be equal to 0. All right, we're going to work for the y and x intercept. So we're going to start, or we'll start with the x, it's where y equals 0. And plug that in, so we get 8. So we're going to plug in wherever x is equal to 0. So 0 plus 8 over 0 plus 0 minus 6 is equal to negative 1/2. So we have 0, negative 1/2. And it's going to be the y-intercept. And so the next thing we're going to do is we're going to find the x-intercepts. And the first thing we're going to do is we're going to factor the bottom. Right, and so I can see that this is going to split into 8 and negative 2. And that's going to be 8 times 2. So our two things is x plus 8, x minus 8. And these cancel. So we're left with 1 over x minus 2. And so there's no x-intercept because there's nothing on top for the equation to equal 0. So none. Horizontal and vertical asymptotes. So we can find our vertical asymptote by looking at our new equation here. We can see wherever the denominator equals 0, and that's at solve this equation, that's where x equals 2. So we have a vertical asymptote at x equals 2. And in order to find horizontal, we got to check our endpoints. So if we plug in like 10,000, that's basically going to go to 0 because that's going to be such a big number, right? Like 0.000001. And if we add more zeros, we're going to add more zeros here. That's going to go to 0. So we have a horizontal asymptote at y equals 0. Right, and if we made that negative, that would just make that number negative. So it goes both ways. They're both going to be 0. Are there any holes in the graph? If so, at what coordinate? We can tell from the first thing, from the first part, that we will have a hole at x equals negative 8 because we canceled out that 0. It was in the numerator and the denominator, so there is a hole there. So now we just plug that point into our new graph, so x minus, and that's going to be equal to 1 over negative 10. So there's a hole at negative 8, negative 10. And then find the domain. So using all of that, we know that we go from negative infinity all the way to negative 8, where there's our hole. Then we go from negative 8 to 2, where our where our vertical asymptote is, sorry. And then we go from 2 all the way back to infinity. Those are the only two things stopping is our hole and our vertical asymptote. Nothing else will limit our domain. So there's that. Question 29. Find a possible formula for the rational function shown. No f of 0 equals -2. F of -4 equals 0. And there's a hole at 8, 6. So, what we can start with what we know. We know where there is a 0, right? So when we plug this into our function, right, that graph is going to be 0. So that goes in our numerator. What we also know is we have a horizontal asymptote at x equals -4. That's going to go in our bottom. And what we also have is we also have a hole. So that goes in both the numerator and the denominator. Great. So now what we have to do is find our leading coefficient, and that just can be found by our endpoints. So this one goes to 2, this one goes to 2, so that means A is going to be equal to 2. Right, and so just to draw all these out, this is the vertical asymptote. This is this is the horizontal asymptote. This is the 0. These are the holes. And that tells us our whole equation. So our equation is f of x is equal to 2 times 4 plus x times over x minus 4 minus 8. Evaluate the limits. So what I know with this limit is that we have two leading terms here, and they have the same power. They both have 2. So I know that when this goes to infinity, these aren't going to matter, right? Because these two terms are going to be the same term. So whenever I go to infinity, when I go to a really high number, I'm actually going to the limit as x approaches infinity of 3x squared over 2x squared, and that's just going to go to 2x squared since these are going to divide. So the answer to the limit is 3/2. For this one, I'm going to rewrite this. It goes to -infinity of x, and this is now written as x over 3 plus 5 over x 1 plus 1. Right, and I know that when we have 1 over x, the limit as it goes to infinity, or negative, it doesn't matter, positive or negative. This number on the bottom is going to be so big, it's going to be 1 over 0, 0, 0, 0, 0, 0, dot, 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 0, that this is going to be equal to 0.0, dot, 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 0, 0, 1, with an infinite amount of zeros in between. So this is going to be 0. So that means that this term is going to go to 0, this term is going to go to 0, and we're just going to be left with 1. So this limit is going to be equal to 1. All right, question 31. Find a possible formula for the rational functions described below. All right, so we can start. We know we have two vertical asymptotes. We know those go in the denominator. So we start x plus 2 and x minus 3. We have a horizontal asymptote of 0. so that we know that there's going to be a higher power on the bottom. The g crosses the x-axis once at at 5, so that means we're going to have a root of x minus 5, and we pass through the point. So we're going to check that with our a. It's going to be equal to y. So a times 4 minus 5 over 5 was 2 minus 3, 2.5. So we're going to simplify that. A times negative 1 over 6 times 1, 5. So negative a equals 6.5. Negative a is equal to 3. So a is equal to negative 3. So that means my function f of x is going to be equal to negative 3 times 5 minus x minus 5 over x plus 2 x minus 3. And so that is the end of part 4. This is the last exam review video. So good luck on your finals, and we hope to see you again.